Okay, we've come to a slightly tricky question. We are still on paper 1. We are now on exercise number 6. Consider the graph of the function f of x, x squared minus k over x. Write down f of mark of x. Right, so this question caused a bit of trouble. I'm going to try my best to explain how it works. So first off, why don't we write down the function ourselves? But I'm going to write it down in a slightly more suggestive way. So I'm going to keep the x squared because that's fair enough. Most people figured that one out. But instead of writing k over x like they do, I'm not going to write it like this. I'm going to think to myself, well, 1 over x. If I have something like that, I can write it as x to the minus 1. So here, what I'm going to write instead is k times, oops, sorry, that's very, very ugly, times x to the minus 1. So why am I going to do this? Well, I'm going to do this because if you use the power rule now, you will very quickly tell, of course, that here you must say 2 times and then x 2 minus 1. But the next one would then be this k, you keep it because it is a constant. This is just a number. We don't know what number, but it's not anything that changes, so we don't have to do anything about it. We just keep it. And then we must bring down a minus 1 from x, then times k, and times x, and minus 1, and then minus 1 again. And that gives us 2x, because 2 minus 1, that's 1, but x to the 1, we don't really care. That's just the same as saying x. Then, because we have a minus on a minus, we get plus k. And then we have over here, instead of x to the minus 1, we have 1 and 1. Minus 1 minus 1, that's minus 2. So we have this. This is actually the answer. Some people figured it out, not everybody, but it's okay. So next one. The equation of the tangent to the graph of f at x equals minus 2, oh goodness me, is 2y equals to 4 minus 5x. Right. First off, we get a question. Write down the gradient of this tangent. So it tells us that the equation is 2y equals to 4 minus 5x. So my question to you is, what is the gradient? And that is also the question that the question asks. An immediate answer is, well, it's this, isn't it? But the thing is, that's only true when this is 1. How are we going to turn it into 1? We'll divide everything with 2. We'll get y equals to 2 minus 5 over 2 times x. Or if you prefer, and some people also do it this way, and I don't really mind either way, it's fine. 2 minus 5x. So you can say this right here. This is the gradient. So here you can say, okay, the answer is essentially 5 over 2, or well, minus 5 over 2, I should say, or minus 2.5. Either of these is an acceptable answer, because you have to remember that this 2 over here is a problem. You have to remember to get rid of it first, otherwise you're not finding the real gradient, you're finding something else. Okay, now the next one. Find the value of k. Oh, how tricky this one was. But there are a number of ways to go about this. I'm going to pick a simple way, which is to go, okay, well, here's the thing. For x equals to minus 2, we have a gradient. For x equals minus 2, we have a tangent. A tangent means that it crosses at that particular point, like it just barely touches. So if I were to draw the graph, it might look something like, for example, I think this one in particular will look something like this. So it might be that it's, say, for example, tangent here. That means it will cross there, but it will also have the same gradient. This allows a few options, but one of them is that, well, if we know the x already, we can find the y very quickly as well by simply saying f of minus 2. Or finding the y via doing the tangent. I'm going to write here t of minus 2. Either one is fine. Let's do the bottom one, because up here we already have the equation actually. Y equals to 2 minus 5 over 2x. So if we do this in full, that will be y is equal to 2 minus 5 over 2 multiplied by minus 2. And then over here, we'll get, okay, minus on a minus, that becomes plus. 2, we divide by and then multiply by, so it goes away. So we get 2 plus 5. We get 7. Cool. So with that in mind, we can use that and we can say, why don't we go ahead and think about that a little bit and say, okay, well, if we've got 7 now for y and an x equals to minus 2, that means that f of minus 2 must give 7. Wow, that's quite cool, actually. That's really useful because here's the thing. We've got here our f. It's x squared minus k for x. So if I give myself a little bit more room, just a little bit more room, I can do this very nicely. So here if I do, so like I said, x squared, and then k, and then x to the minus 1. If I do here, minus 2 squared, and then after that, minus k times minus 2, or maybe I should be more simplistic here and say k divided by minus 2. This should be equal to 7 if k is to work. Okay, well, let me give me a little bit more space, That would be then 4, and then plus k over 2, which should be equal to 7. But now, if I isolate further, I can quickly find that I get k over 2 equals to 3 if I subtract 4 from 7. And then I can see, well, look at that. I can do k equals to 6. And that's that. That's actually the solution, k equals to 6. Something that I haven't really had a chance to talk about, but I'll probably mention it more in class, is a little thing that I did here. You see here, I do a little arrow sign. It looks like an equal sign, but it's actually an arrow. And the reason that I do this is because if I just did an equal sign, if I just did k over 2 equals to 3, and then I said O equals to k equals to 6, this doesn't make any sense. This is very confusing because it's like if I looked at this in isolation and I said, wait a minute, hold on, are you saying that 3 is the same as 6? No way. That's the sort of thing that will cost you marks on the exam, so don't do that. Use an arrow instead, just very simply. It's literally like just doing this, like putting a little arrow sign on there will save you marks. So if you ever go like, oh, I've got this, but I want to keep going, just use like an arrow. Just use an arrow. Please use an arrow. But yes, that's the essence of the question.